So in this question, he wants me to find the value of the integral x squared multiplied by e to the power of 3x dx using integration by parts method. This type of questions usually comes in exams because there is a specific trick that we will realize in this video. I'll have to use first, or let's recall, the function of integration by parts. That is basically f prime times g is equal to f times g minus the integral of f times g prime. And therefore, I need to determine which one here is my f prime and which one here is my g. So as f prime, I will take e to the power of 3x, because I know that when I integrate that, it's basically going to give me almost the same function all the time. So I don't really have to worry about it. And if I differentiate the other function, x squared, then at one point it will be 0 or it will be a constant. And therefore I'll only have one function, my integral, which I can integrate easily instead of two functions multiplied with each other. And so therefore I'll integrate the function f prime, or e to the power of 3x, and the integral there is equal to e to the power of 3x over 3, and g prime will be 2x. And then I just use my formula. Here I substitute in my values, so I will have x squared multiplied with e to the power of 3x over 3 minus the integral f, and f is e to the power of 3x over 3 multiplied with 2x dx. Now I can simplify this, rewrite it in another way. I'll have x squared multiplied by e to the power of 3x over 3 minus 2 over 3, I can pull outside the integral, e to the power of 3x times x dx. And you can already see here the function basically got a little bit simpler. It was x squared times e to the power of 3x, and now it is basically only x times e to the power of 3x that we need to integrate. And the goal of the integration by parts method is always to make the function that is in the integral simpler, possibly only one function and not two functions multiplied with each other, so that it could be solved. And here we realize that we need to use the integration by parts method another time, and this is the trick. So we need to determine another f prime here, and we take the same f prime as e to the power of 3x, and f is, integrate that as going to be e to the power of 3x over 3, and our function g is going to be x. Now differentiating that will give me only a 1. So, and then I apply my formula, this one right here. So here we go. And so therefore, I just use my formula, I substitute in the values, and I will get x squared. Let's not forget the beginning here, x squared times e to the power of 3x over 3 minus. Now, this formula only has to do with the integral right here, so let's not forget the 2/3 here. We need to include those. I'll have 2/3 multiplied with parentheses, and now I use the right side of my formula. And that is going to be...
If you got any unsolved problem in the world of numbers and equations, make sure to comment it down below and we can get it solved.
E to the power of 3x over 3 times x minus the integral of 1 times e to the power of 3x dx. And 1 times e to the power of 3x is just going to give me e to the power of 3x. And therefore I'm pretty much done. All I need to do is solve this integral right here. And I've already solved this a lot of times. This is going to give me e to the power of 3x over 3. And so therefore, I'll try now to simplify. So minus 2/3 parentheses e to the power of 3x times x over 3 minus e to the power of 3x over 3. And let's not forget the integration constant. Now all I need to do is simplify. Here I can factorize the 1/3. So I'll have 1/3 multiplied with x squared times e to the power of 3x minus 2 parentheses. This 2 is multiplied, so here we will use the different parentheses so we can differentiate. This 2 is multiplied with the rest here, so that is e to the power of 3x times x over 3 again minus e to the power of 3x over 3. And here I can already factorize e to the power of 3x. I can factorize that. So what I will have is, how do you write this? Or how do you write it in the line under it? So here plus c. And if you notice here, I can also factorize the 1/3. And that's not gonna be a problem with the constant here, because if I multiply with a constant, or if I add to the constant, or if I divide, this is gonna be a constant at the end of the day. I'm gonna have 1/3 multiplied with x squared times e to the power of 3x minus, now 2 over 3, factorize the 3, times e to the power of 3x, now into x minus 1 plus c. Or what I'm gonna do here, I'm gonna remove the constant, and I'm just gonna add it at the very end, because at the very beginning, all we had is this one integration, and it's supposed to have one constant only. So let's not get confused with that. And then let's not forget big parentheses. And then we can see also here, we can factorize this, e to the power of 3x in both functions. And therefore what we can have is e to the power of 3x over 3 into x squared minus 2x over 3 minus 2/3, or you multiply this negative with this negative, so it's going to be plus 2/3, and then at the very end plus my constant, and that is going to be my final answer for this problem.
Don't forget to subscribe to Sam's Education channel and hit the notifications bell to receive regular updates and access to a variety of solved exercises. See you in the next video.